Let's look at lecture 3 of IPv4 addressing. This one's on network segmentation. Basically what we're doing, segmentation says I'm breaking down a network into smaller pieces. Because because when you send a bit of information out, and if I didn't break down my network, that means every packet of information has to be interpreted by every single computer on that network. And if I looked at the whole college and say, gee, I've got 3,000, 4,000 IP addresses, every one of those devices looking at every single packet of information that comes across, the network would be super slow. So what we've done is we've segmented. Let's find ways to shorten or shrink the size of that network so that I don't have to send every information to every other computer that I'm connected to. So basically, I don't want to have to read every bit of information. Now, in an Ethernet LAN, devices use broadcast address and address resolution protocol to locate other devices. You learned that the address resolution protocol, ARP, sends layer 2 broadcasts to a known IP4 address on a local network to discover its MAC address. Devices on the Ethernet LANs also locate other devices based on its configuration using dynamic host configuration protocol, DHCP, which sends out broadcast messages to locate a DHCP server. I need to find the DHCP to give me information back so I can populate all the information I need. Now, one thing to keep in mind is switches will always propagate a broadcast messages out every interface except the one that it was received on. A router does not forward broadcast messages. So that is called a broadcast domain. Where that broadcast message is terminated and not forward, everything in that network is a broadcast domain. So in this picture here, you've got an interface G00 that's connected to the router, and everything on those 4 switches are in the broadcast domain. So all those switches, if somebody's looking for information, it will send it to all those other 4 switches, but the second it hits that G00 interface, the router does not forward that broadcast message on. So just keep in mind, routers do not propagate that. Because there are some problems. If you have too large of a broadcast domain, it causes, you just got too many hosts. And there are some problems with that is you start generating excess amount of broadcast messages, which has an impact on the network, slowing it down. Could you imagine 400 hosts trying to broadcast information because it doesn't know enough information about everybody else there, and it keeps asking for information? It just becomes totally unusable. So if you had 400 users, that you just got tons of information. So the trick then is saying, well, how do I create smaller broadcast domains? Well, that is done by a process called subnetting. I'm going to break down my network, this LAN 1, into smaller pieces so that I am not sending information to 400 users. Maybe I'm sending it to 200. I can create a subnet of 200 users versus 400. So subnetting is basically just a way of how do I shrink the size of my broadcast domain. Now, the question then becomes, how do I communicate between networks? One time I had 400 users on one network and I can communicate to everybody. Yeah, I may have had too much traffic, but I can still do it. But now once I've subnetted The only way you can communicate between networks is through a router. So this is the purpose of the router, is to locate other networks. Now, if you look at the example they've got here, you've got LAN 1 is 172.16.0.0 and for 200 users. And now I kept my subnet mask the same, so it still says 255.255.255 is my subnet. It says that is everything in that 172.16.0 and beyond is a subnet, and everything in the 172.16.1 network, all its users are there. So the prefix length, instead of 1, because remember what happened when you saw 172.16, what was its prefix length? Its prefix length was 16. Basically what I've done is I've cut that single 16 network /16 network into 2/24 networks. Basically I'm now using host bits to create additional network bits. So I'm creating other networks based on just using host bits. Now, why would I do this? Well, there are several reasons. One, it reduces traffic to the overall network. It improves performance. It allows me to do a little bit of security, so information doesn't travel, beyond its original intent. So it can be based by local, location, could be done by organization, could be done by device types. Each one of those has a different change or different reason for wanting to do this. So it just kind of makes sense for network administrators to create subnets just so they can keep track of how much data has been, where is it going, so if it has any other issues. So you just want to, take check. Now, go ahead and take the quiz on network segmentation. And I think I want to stop on this video and we'll start a whole new one on subnetting an IPv4 address.